Hey, my name is Johan, and I work here at Noodl. This is the 5th video in which we introduce you to Noodl. We're building a fully functional to-do list web app, so please follow along in Noodl and build your own version as we go. In this video, we'll show you how easy it is to connect to a real cloud service backend in order to store and manage your data, which in our case are tasks for different users. Noodl comes with built-in nodes that makes it easy and quick to work with data. In this video, we will introduce a lot of new concepts that are related to working with backends and databases. If this is your first time working with a database or backend, I encourage you to pause and re-watch sections that introduce these new concepts and nodes, such as the model, collection, and for each node. You can also find all the documentation and written guides for how to work with the data nodes on our documentation site, and the link is in the description of the video. So let's jump in and start populating our app with important tasks. I'm going to click the Cloud Services button so that I can bring up the dashboard for my app's backend. I want to be able to save tasks in my backend, so let's create a new class that can hold my tasks. Let's call it Tasks, no surprise there, and make sure that the type is set to custom like it is for me. When a new class is created, it will have a few default columns, but we want to add some more. For each task, I want to save a task description, which user it belongs to, and if it's done or not. So let's add 3 columns to this class. First, let's create a column for task description, which will be a string. Next, we add another column with the type Boolean, and we will give it the name task done and set its default value to false. Lastly, we add a column for the user ID. It will be of the pointer type, and we want the target class to be our user class, and we will call it user ID. And that's it for setting up the class or table in the backend. Now let's jump back to the main page and see how we can use this class or table. We will now start using some of the data nodes, and specifically, we'll use a model node and get it hooked up so that it will insert new tasks in the backend. Later, we will see how we use a model to get and display data from the backend. But like I said, let's first use it to add more tasks to the database. So in our main page, let's add a model node. The model node is a representation of an item that we can store in our backend, or a representation of what is already stored there. So let's tell this model node to look at the tasks class from our backend. I now want to set up the model node so that it takes a task description from the task text input component and creates a new task for me in the backend. To do that, we make a connection from our task text input component to our model, and we can see that the model has inputs for the columns that we just created in the backend. So we see the task description, task done, and user ID. Let's connect the text value from the task text input to task description. We will make a few more connections soon, but first I want to make sure that we only create or insert new tasks in the backend when the task text input component is showing. The model node has an action called insert, and this is what we want to send a signal to in order to create a new task in the backend. To make sure that we only send a signal to the model when the task text input is showing, I'm going to use a condition node. I'm calling the condition node only do insert when at show to make it clear what it is supposed to check. We connect the at show output from the states node to the condition input of the condition node. The at show will be true when we're in the show state and otherwise false. And we want to evaluate this when we click the floating action button. Now, if the condition evaluates to true, then we want the model to do the insert action. So let's make a connection like this. I'm also realizing that I want the task text input component to clear the input field once a new task has been created in the backend. Let's jump into the task text input component and add another port on the component input node and call it clear. Then we want to connect the clear port from the component inputs to the clear action on the text input node. I'm jumping back to the main component because now I want to make a connection from the model node to the task text input component. The model node will send out a created signal once it's done with the insert action, and it is then we want to clear the task text input. We still need to connect a user ID to the model node, and we get that from the user node. So I add a user node and connect the ID to the model's user ID property. We don't need to connect anything to the task done property, since it will be automatically set to false if we don't provide a value. Let's try it out. I'm going to start the preview window, log in, and now I'm going to type in a new task description. Let's call it test task 1 and click the add button. We don't see anything change in our app yet, but let's have a look in the dashboard. If we have a look in the task class, we can now see that it has one task with a description and a user ID and the task done set to false. This is great because it means that the work we just did is working as it should. If your dashboard was open from before, you might need to reload the dashboard to see the newly inserted task. Before we continue displaying the tasks from the backend, let's take a short detour. You might have noticed that every time we preview the app, we need to log in. The backend actually keeps track if a user has been authenticated across sessions, so we can actually make it so that we don't have to log in until a session has expired or we have logged out explicitly. Let's add this by going to the app component. We will add a user node and a condition node. Let's connect the authenticated value from the user node to the condition port of the condition node. Then let's add two navigation nodes. One I will set up to navigate to the main page, and I want to do that without any transition. If my condition is true, it means our user is authenticated. Then I want to navigate to the main page, so I make that connection. The second navigate node should go to the login page. And I want this to happen if the condition is false, meaning we don't have an authenticated user. Now if I preview my app, you can see that we go directly to the main page, and that's because we have an already authenticated user signed in. Okay, so now that we've taken a short detour, let's look at the main page again. We now want our app to display the data that we have in the task class or table in the backend, so let's work on making that happen. First, let's remove these task items that we used to get a feeling for what the app would look like. Let's add a new node to the ListItems group, a for each node. The for each node takes an array of items and generates a component for each item in that array. And we can get an array of items from a query collection, so let's add one of those. A query collection is a node that you can use to set a query for a class in your backend and then retrieve a set of data that matches your query. So one of the first things we need to do is tell the query node what class or collection name it should look at in the backend. In our case, it's the tasks class. When a query collection has retrieved data, it will be available on the result output. So let's connect that to the items input of our for each node. We also need to tell the query collection to execute its query or fetch data. And a good time to do that is when the main page component is mounted in the node tree. So we connect the didMount signal to the fetch action of the query collection. Now, when the main page is mounted, we should see that we get some results from the query collection. So let's preview our app. Did you notice the little animations on the connections? That tells us that there is data on the connections, so let's inspect it. If I hover over a connection, it will show me what data is currently on that connection. And if I click the little pop-up, I can pin it so that it doesn't disappear when I move the cursor. And look at that. Here we have data from our tasks class. But why isn't it showing in our UI? Well, we need to tell the for each node what type of component it should generate. And in our case, it should be a list item. And now we see one list item in the UI, but it's showing our example data from before, so let's change that. In the list item, let's first do a little restructuring. The text and circles with the not done and done states are really a checkbox, so let's create a new visual component called Checkbox. We cut out all of these nodes from the list item and paste them into the checkbox component after I delete the default group node. Now let's drag the checkbox into the list item and we're back to where we were, but with a much simpler looking list item. The for each node will generate one of these list item components for each entry in the items array. And if we had a component inputs, the for each node would try and map the column names from the items data, like task description and so on, to inputs that have the exact same name. So we could do that, or we can also get the data from a model node if we can provide the model with a item ID or model ID. Let's add a model node, point it to our tasks, and talk about how we can give it the correct item ID or model ID. So like I said, the for each node will try to map column names like task description and so on to a component input port that has the exact same name. One of the column names is always called ID. So if I add a component inputs with a port named ID, the for each node will extract the correct ID value from the items array and put it on this component inputs port. I could also use a for each item node. The for each item node will get the model ID from the for each node for the item that is supposed to be created, and it will be on the item ID output. But this is exactly the same as our component's inputs with the ID port, so let's use that and hook it up to the model. With the ID hooked up to our model, we can get the correct data out of it, but we want that data to go into the checkbox component we just created. So let's jump in there and make some component inputs. I'll make a port called label and connect it to the text property of my text node. Then we'll add another port called state that we will hook up shortly. Let's also add some component outputs. One that we will call click and one that we will name state. We want to be able to know what state the checkbox is in, so we connect the @done from the states node to our state output, and we connect the click signal from the top group to the click output. Before we finish hooking up all the state connections, let's go back to the list item and hook up the task description from the model to the label input of the checkbox. Voila! Now we see the correct task description in our UI. Okay, back to the done, not done state. Before we hook everything up, let me try and explain a bit of what we're trying to do. In the data for our tasks, we keep track of if they are done or not. So we want to take that value and use that to set the visual representation correctly. When the user interacts with our app and changes the visual state from not done to done, we want to make sure that we also update this in the backend. The model node has both inputs and outputs for all the data fields or column names. The model also has an action called save, and when you execute that action, the model will look at what's connected to the inputs and take those values and save them in the backend. So we're going to end up with having both input and output connections from the task done property of the model. Let's hook it up and let's see if it makes sense. First, let's connect the task done output from the model to the state input of the checkbox. This is what will tell the checkbox what state it should show initially. Next, let's make a connection from the checkbox's state output to the task done input of the model. This is the new state of the checkbox after a user has clicked it, so let's connect the click signal from the checkbox to the save action of the model, so that we can update the backend as we interact with the app. Finally, in the checkbox, we need to hook up the state input to the states node. The input is a Boolean, and the state in the states node is a string, so let's use a Boolean to string node to do that conversion. We connect the state to the selector property, and then we set the string for true to be done, and the string for false to be not done. And then we connect the current value from the Boolean to string node to the state input of the states node. It's important that the strings that the Boolean to string outputs are exactly the same as the state names, otherwise this won't work. Okay, so let's test it. I click the checkbox in my preview and the visual state updates, and it will also be saved to the backend so that we are always showing and storing the correct value. While we are in the list item, let's go ahead and add a component output with a port that we name updated. Once the model has completed the save action, it will send out a changed signal that lets us know that the model has been updated or changed. And we will want to use this signal very soon, so that's why I'm setting it up now. And if I click the checkbox in my preview, I can see how the data is flowing on my connections in the node editor. Next, let's add an array filter node. We'll be using this to update the number of tasks left to do in the header. When the task is not done, we see that in the backend the task done value is false. And if I check the task, the value changes to true. So we want to filter out all results from the query collection where the task done value is set to false. First, let's get the results from the query collection into the array filter by connecting the results to the items on the array filter. Then let's select the array filter and set up the properties. I'll click the plus sign to add which column in the task class I want to filter on. In our case, it's the task done column. Now a new filter is created, but I need to tell this node that the task done is of the Boolean type. I'll keep the operation to equals since I want to filter out all items where task done equals false. So I will leave the checkbox here unchecked. The array filter node will actually create a new array with all the items that pass through the filter. But we're only interested in the count, meaning how many items there are in the new array. So for now, let's connect this output to a number. The number says that the count is 0, and that's correct. We only have one task, and it's already done, so the task done property will be true. So the filter will give back nothing. Now, this next part is important. We need to rerun this filter every time we update a task. So if I click on a list item and it updates its done state, we want to run this filter again. Luckily, we already added an updated output to our list item, and our friendly for each node here exposes that output for us. So let's connect the updated item signal from the for each node to the filter action of the array filter. Let's also make sure that the filter runs immediately after our query collection has fetched all its data by connecting the fetched signal from the query collection to the filter action of the array filter. Now if I hover over the number node, I see the little pop-up that says 0, which is its current value. If I click that to pin it, and then interact with my app, we see that it updates as my task is either not done or done. Pretty neat. Now let's display this number in the header component. First, in the main header, let's add a component input node and add a port that we will call tasks left to do. Let's connect that to the text property of my number of tasks left text node. Now let's go back to the main page and connect the count from the array filter to the main header input. And let's update the task to verify that it's working. Very nice, but let's make really sure, so let's add another task. we added a new task, but we still only see one. Let's see what needs to be done. So remember down here in my main page, we have a model node that we use to insert new tasks in the backend. Well, we need this model to tell the query collection to do another fetch every time we put a new task in the backend. So we could do that right here, but this component is starting to get quite big, so let's refactor a bit before we make the connection. I'm going to create a new visual component and call it Add New Task. Then I'll just move it to an empty space in my component canvas. Next, back in the main page component, let's select all these nodes at the bottom here and cut them out. Go back to my Add New Task component, delete the default group, and paste in my nodes. Now, before we add this back to the main page, let's add a component outputs with a port called task created, and connect the saved signal from the model to the task created port. Well, let's rename it to task saved. Now we go back to the main page and drag in our add new task component and place it here in the node tree. And now we're going to connect the task saved output to our query collection's fetch action. So let's try again to add a new task. Test task 3. And when I really click the button here, voila, we see all our tasks. We see the one we just added as well as the second one that we added. The second one was created successfully before, it just didn't show up in the UI, but now after we tell the UI to update correctly, we see them all. And let's check some of them off to see that the number in the header updates correctly. Nice. This is great, but it would be even better if we could delete tasks after they're done, so let's add that quickly. Let's go to the list item. I want to add a delete button, so I'm going to use the material UI icon pattern again. I create a group, call it delete task, and then add a material icon as a child to it. Then the important step. I set the group to the size of its child or children. Let's add it to the list item like this. Select the icon node, and then change the icon property. You can find the names of the icons on Google's material icon site, and we will use the delete icon here. I only want to show the delete icon if the task is actually done, so I can use the task done property, which is a Boolean, to control if the delete icon is mounted or not. It will be mounted if the task is done, and not mounted if the task is not done, so that's perfect. Also, let's make it slightly bigger. Next, when we click the delete icon, we want to delete the model, so we make a connection like this. Let's test it, deleting the first task and it's adios. Same for the second task, and finally the third. See ya. Now let's add some real tasks for me to do. Those pancakes were so good I almost forgot the final thing. Right now, our query collection in the main page fetches all tasks that are stored in the task class. But each task is associated with a specific user, so we should really only fetch the tasks that are associated with the currently logged in user. Let's do that by adding a filter to the query collection. We will filter on user ID, which is a string, and we want to check that it's equal to a specific value. That value is the signed in user's ID, and we get that from the user node. So let's connect the ID from the user node to the value of my filter, and now we have a fully functioning app. Okay, so here we are, a fully functioning to-do list app. It took us little over an hour to get here, and I hope you'll continue building on this or some other application in Noodle. In the next video, we'll have a look at how you can deploy your application to the Noodle cloud and how you can run it on device. Thanks for watching, and please join us on our Discord server and share your Noodle journey with our growing community.